Welcome. Today we'll be discussing the idea of composition of transformations. Now, the word composition, all it means is that we're going to be performing more than one transformation in an object. Sometimes a point, sometimes a full figure, but just when you hear the word composition, it just means that we're going to be performing more than one transformation on the same object. All right, so let's start by looking at some examples. We'll start by defining what a glide reflection is. A glide reflection, it's a combination of a translation and a reflection transformation. So when we talk about glide reflection, we're talking about performing two actions on the object, a translation and then a reflection. So how does that exactly look like? Well, let's take a look at example 1. Here, let's start by plotting the point A, which it's already done here for us, at 1, comma 3. And let's perform the glide reflection. So first, let's perform the translation. So let's understand the notation. The notation here says, look, get a coordinate point x and move it 2 units to the right. So A, if we move it 2 units to the right, is going to be right here. And notice that I'm only moving it 2 units to the right because y, it gets mapped to y. So the y doesn't change and the x gets moved 2 units to the right. If this would have been a subtraction, then we would have moved 2 units to the left. So notice that we have done one transformation. So therefore, this point right here, we want to refer to it as A with 1 prime on it. So that's just saying I have performed one transformation on A. But since we're doing a glide reflection, we got to perform two transformations. So translation, it's already done. So now let's reflect our image. But now we got to be careful when we're doing this because we're not going to reflect the original, but we're going to reflect the image of what was given. So let's reflect A. And again, remember that one of the properties of reflection is that uh, the point should always be equidistant to the line of reflection. So what is the line of reflection that we're interested on? The line of reflection that we're interested on is the x-axis. So here we have our x-axis. So let's just reflect this object. So if this is A prime and we reflect it, well, A prime is 1, 2, 3 units away. So therefore, after performing this reflection, it should still be 3 units away. So we go 1, 2, 3. So the product of that reflection should be somewhere down here. But let's be careful with the notation now. Because now this point is the result of performing two transformations. So therefore, this point, it will be considered as A prime prime. So note that it's not that clear there, so let me just rewrite it one more time. Because A prime prime. Every single prime that put on top of a letter, that indicates that that's the image of how many transformations that we have gone. So notice that this point down here is the product of performing two transformations. My first transformation was a translation, and then I reflected. So therefore, this point is the product of two transformations. Therefore, it should have the notation of A prime prime. And again, composition is just the idea of performing more than one transformation of an object. Let's perform another glide reflection real quick. Still, let's start by still putting our coordinate point at 1, comma 3. So 1, comma 3. So here we have our A, just like we have it here. Now let's perform this translation. What this translation is saying, look, my X values, I'm going to move it 4 units to the left. And also my Y values, I'm just going to move it 3 units up. So let's take a look at A. And at A, we're going to move 4 units to the left. So 1, 2, 3, 4, and 3 units up. 1, 2, 3. So notice at this point is the product of performing a translation. So therefore, this point is considered as A prime. Now let's perform a reflection on the line y equals 2. Well, y equals 2, it's essentially this line right here. So let me just do it in dotted. So this dotted line will represent the line y equals 2. So let's just reflect. Let's just reflect our a prime point. So if we want to reflect it with this line, I know that the distance should remain 2. So if a prime is 1, 2, 3, 4 units, then the reflection should be 4 units away from the line as well. So that would be 1, 2, 3. Let's just say that it's somewhere around here. And notice at this point, it's the product of performing 2 transformations. So therefore, this point should be labeled as a prime prime. We perform one transformation, so that's a 1 prime. We perform a second transformation, so that's a prime prime. So let's just perform one more glide reflection just to be sure that we're okay with it. So again, let me just choose the same point, 1, 3. So I guess you just gotta be careful here because now every square has a unit of 2, so that's 1, 3. So that's somewhere around here. That'll be A. And again, let's perform our translation. This is saying that X is going to get moved 3 units to the left, and Y is going to get moved 2 units up. So let's get our point A, and let's perform that translation. We're gonna get A, and we're gonna move it 3 units to the left. So that will be 1. So that'll be about here, and let's move it 2 units up. And again, every square it's a 2 units, so that should be somewhere around here. So this will be considered my A prime since I have only done one transformation. Let's perform the reflection over the line x equals 2. Let's see, where is x equals 2? Well, x equals 2, it's this vertical line right here. So let's just perform our reflection. So notice that this point is 4 units away from x equals 2. So therefore, after performing our reflection, it should still be 4 units away. So that would be 1, 2, and that would be 4 right here. So now notice at this point, this was 4 units to the right. So after performing the reflection, that should still remain still. So now at this point, exactly right here, this is where A prime prime is located at. So these examples were more than anything for you to just get comfortable with the notation. And for you to get comfortable with the idea that we can perform more than one transformation of an object. And right now we're just doing a single point. We're going to move on to full objects in a second. So now let's just recap some of the notation. Well, this is a very important notation right here, because as to indicate the image of the first transformation, we only use a single prime. So pretty much the primes, or this little symbol that we put on top of letters, that indicates the image of what transformations. If you perform 2 transformations, then we do double prime. If you perform 3 transformations, then that's a triple prime, and so forward. So even though these examples are labeled as group work, I would like to go over some of them so you feel comfortable with this concept. Oops. So let's start by looking at example 1, which says, let's describe the composition of the transformations. Notice the word composition. So this means that we are going to be doing more than one transformation of an object. Well, let's take a look at how the image is presented to us. So here we have, let me do highlighters because highlighters are good. So this is, notice that just by looking at the notation, this is too much. Notice that by just looking at the notation, This triangle doesn't have a prime anywhere, so that's just A, C, and B. There is no prime on top of it. So we can think of this as the original image. This is the original image because there is no prime on top of it. So that means that this is the object that we start with. Now notice that the triangle on top of it, this dotted triangle right here, they all those letters have one single prime on top of it. So that's an indicator that this is the first image. So the question now becomes, what can we do to this triangle so it actually lands on top of this dotted triangle? Well, notice that if we get every single point and we reflect it over the line, over the x-axis, because let's just take a look at this x-axis. If we reflected this triangle over the x-axis, notice at this point C is going to go to C. But now, this A, it's 2 units away from the line of reflection, which is also 2 units away after the line of reflection. So notice that if we get A and we reflect over this line, it's going to land on top of it here. And the same can be said about B. The same can be said about B. Here we have B, and if we reflect it, or if you get this object and you just flip it along this line, notice that this point is going to land exactly at this point. So the first transformation that we did, we perform a reflection over the line. What would this be? Y equals 0, which is another way of saying is the x-axis. So that's the first thing that we did on this object. So now the question becomes, what can we do to this image now? What can we do to this triangle so it moves, or I'm sorry, I think I already gave it away. But what can we do to this triangle so it lands exactly on this second triangle? So the first thing you might notice is that it's definitely not a reflection. It's definitely not a reflection, but notice that it has the same orientation here. So you can just think about getting this triangle, and it seems to just be a solid movement. But now let's think about by what units. Let's think about what units are we moving this triangle. Well, point A prime, how many units do we need to move it so it goes all the way to A prime prime? Well, that would be 2 units up. And that would be 1, 2, 3, 4, 5, 6 to the right. So 2 units up and 6 to the right. Now, does every single point in here has the same movement? Well, I don't know. Let's see. From C to C prime, 2 units up and 1, 2, 3, 4, 5, 6. So it lands there as well. B, 2 units up, 1, 2, 3, 4, 5, 6. So notice that it works out. So what we have done now is that first, the original object, we reflected over the x-axis. And then we shifted, or we translated the triangle 2 units up and 6 to the right. So the first thing that we did, we reflected over the line y equals 0, which is the x-axis. And then we translated the object triangle A prime B prime C prime 2 units up and 6 units to the right. So that's all we're doing. We're just applying different transformations. We could have moved that object even one more time. When we talk about composition, we're not just restricting ourselves to just 2 transformations. But in this example, we're just doing 2. All right, let's take a look at example 2 now, or example B. Let's think about this for a second. The first thing that you want to do is identify the original image, which in this case, it's right here. Because notice that this triangle doesn't have any of the primes. So this is just saying that this is the original pre-image. And now let's think about this for a second. What exactly did we do to this triangle so it lands not of this triangle, because notice that this triangle has C prime prime, A prime prime, so that's double prime. We want to first land it in single prime. Well, it's definitely not a translation, because if we get this object and we shift it, it definitely is not going to look like this. Is it a reflection? Well, if we get this object and we reflect it, it should look something like this, somewhere around here, just like I'm doing with my cursor. So it's definitely not a reflection. So what is it exactly? Definitely not a dilation. It seems to be the same shape. So it must be a rotation. But now, how many degrees are you rotating this figure? Well, let's take a look. We can figure that out. Because now this point is 1 comma 1. And this point is negative 1 comma 1. So A is 1 comma 1 and A prime is negative 1 comma 1. C is 1, 2, so that's 3 comma 1, where C prime is negative 1 comma 3. And I feel like at this point you can start seeing the change, because remember that when we reflect over the origin 90 degrees, every single coordinate point gets moved to a negative y comma x, which is exactly what's happening here. So notice that we have our first transformation here. Our first transformation is that we reflected over the x, we reflected over the origin. We reflected over the origin with an angle of rotation of 90 degrees. So that's the first thing that we did. All we did, we got A and we rotated 90 degrees. That's all that has happened here. Okay, so now we are at A prime, B prime, and C prime. So what exactly can we do to this object? What exactly can we do to A prime, C prime, and B prime? So what exactly can we do to this triangle so it maps exactly on the triangle below? So notice that A should get landed here, C should get landed here, and B should get landed here. But notice that A is 1 unit away from the x-axis, and A prime is 1 unit away from the x-axis as well. C prime is 3 units away, and C double prime is 3 units away. So you can start seeing that this will be an example of a reflection still over the x-axis. This will be an example of reflection over the x-axis. So the first thing that we did, we reflected over the origin with an angle of rotation of 90 degrees. And now, in order to land A prime, C prime, B prime on A double prime, B double prime, C double prime, what we did after that, we reflected triangle A prime, B prime, C prime over the line x equals 0. I'm sorry, not x equals 0. Y equals 0. Or another way of seeing it, we reflect that over the x-axis. So now that all we have done is we're combining different transformations. So we're not just reflecting it once and then that's about it. What we're doing more than one transformation to an object. So that's pretty much the idea of a composition. A composition of a transformation is just applying multiple transformations. And after performing multiple transformations, you get an overall image. And again, the most important thing here, or one of the most important things, is to understand the notation. Hopefully this was helpful, and I will see you in class.